the thymus is very active. And the next one is going to be another thymus section, and that is 35. And on slide 35, I go back again to the lowest power, and we just try to remember the previous one and try to compare it to this one.
I hate when it has lines.
So you see that it is much less cellular. Also, if you go into the deeper layer, you're going to see that the septa are much wider. In several places, this is not a very late thymus, but it would be full with fat tissue that I don't see here. So this is still active. We still see lymphocytes around here, but we also see the enlargement of this Hassel's corpuscle. In the other section, it was hard to recognize that. If you look at these here, it is very easy to recognize that they are much larger. And if we zoom on them, you're going to see that concentric onion-like structure of these epithelial reticular cells that are rolled up in this Hassel's corpuscle. I'm moving to the 10x objective, so we see a little more. This is not very good. 20x. Okay? So yeah, with the 20x we actually see that these round objects are composed of cells, and they are degenerating, and when they get really big, in the center we're going to see cytokeratin. That also just tells you that the cells which which this come from are epithelial cells, because there is cytokeratin in them. Okay, so the epithelial origin is very important. Please don't remember, because that's one of the most important things about the thymus structure, that the stromal cells are epithelial cells. Again, you see the small lymphocytes everywhere here in the cortex, but if you remember the previous one, this is much less cellular. There are less cells. And if we go and use the 40x objective, what we're going to see is much more, the stromal cells will be much more exposed because there are less lymphoid cells around, and the macrophages will be much more easy to recognize, and we're going to see the blood vessels more easily, and I'm going to pull up this one right here, and we're going to zoom on that with the oil. Okay, so here you see the blood vessel, and if you remember the blood vessels, this is likely the endothelial cell, and then there is the other endothelial cell that the nucleus here protrudes towards the lumen of the blood vessel, and then you also see this cell right here surrounding it. And also not the perfect, but there are several layers probably that are around it in other parts of the tissue. So these cells, these epithelial reticular cells, provide, one is a physical barrier between the antigens, like the antigens are in the blood, right? So the antigens are circulating here in the bloodstream. So the cells, these epithelial reticular cells, provide a physical barrier, but they also provide another barrier, because they have certain cell surface molecules which will not allow these the cells, the already developed immune cells like B lymphocytes, to migrate out into the tissue. So these cells do not only provide a physical barrier, but they also provide cell surface molecules which will help to carry out this function that the antigens don't get out into the tissue. And if you look at them, it is a little bit easier to see the processes of these cells. Just imagine that these cells everywhere are connected to each other. If you look at these lighter cells, these are the epithelial and epithelial reticular cells. Also, those macrophages, we talked about the macrophages, that is something with lots of debris in it. If you look at this guy here, again, a macrophage, or this one right here, this is again a larger cell, maybe more intact with less phagocytosed material. So they are everywhere. There are lots of macrophages in here. And if you want to look at the large epithelial reticular cell, it's right here. Again, there still can be cells where we see lymphocytes in the cytoplasm. Maybe tiny nerve cell here. What happens here is, you see this lymphocyte, it looks like they are in the cytoplasm of that large cell. So there may be tiny nerve cells. Again, to prove that, there was a quite long period of time when also these were described by pathologists that these tiny nerve cells exist. There was a big debate about whether the lymphocytes are inside the cytoplasm or they are just surrounded by these cells and they just attach to it. And it was only recently when these cells, these thymic Schnommel cells, could be cultured in vitro, and in vitro cell culture, they could be, the scientists could show that they are able to engulf and have the lymphocytes inside the cytoplasm. So they really nurse them inside the cytoplasm. Blood vessels. So these are the most important things about the thymus. If you want to look at the bone marrow again, we just have a bone marrow, and you have to recognize it. How do you recognize the bone marrow? You see the megakaryocytes, right? But please remember that the bone marrow is much more than we thought 20 years ago or just 10 years ago, because also all the T cells and B cells start to develop in the bone marrow. Okay? Thank you.
That's it.